Bienvenidos y bienvenidas al webinar número 21 de INCOSE Latam y vamos a pasar a inglés. So, this book presentation, Model-Based Product Line Engineering, the Feature-Based Path to Product Line Success. This webinar presents the book Model-Based Product Line Engineering, the Feature-Based Path to Product Line Success, offering a comprehensive overview of both the management and engineering dimensions of model-based product line engineering. The book addresses real-world challenges and implementation experiences, focusing on the practical obstacles organizations face when adopting model-based product line engineering, and how to overcome them for successful, scalable adoption. The message is clear and relevant to all engineering organizations. No one builds just one. The speakers. Marco Forlingeri is Senior Director for Solutions Engineers and PTC, leading worldwide the PLE technical area with several years of experience in PLE and model-based systems engineering domains across Asia, Europe, and the US. He is also chair of the INCOSE PLE International Working Group. Hugo Guillermo Chale Góngora is Head of Product Line and Multidisciplinary Analysis and Optimization at Airbus, with over 24 years of experience in systems engineering, model-based systems engineering, and model-based product line engineering in different industries, and founder of the PLE International Working Group at the Automotive Working Group of INCOSE. So thank you, Marco and Hugo, and now you can share your screen.
Thanks for the invitation, Adrian. Thank you. Good morning, everybody. So, Marco, if you can share, I will start. We will start the presentation together.
Can you share? So we switch.
I cannot share. I'm connected with my Airbus account now.
Okay.
So I cannot. Sorry for that. Okay, so here we go. Nice to be with you. We could have done it in Spanish, but Marco is a little shy with his Spanish. He speaks very well, so we'll keep it. We could do it in English. So the menu for today is just a little brief introduction and the motivation to go to model-based product line engineering. Then Marco will go through the foundations, implementations, and I'll come back to adoption, and we'll together go through industrial cases and the conclusion. So Marco, if you go ahead, let's get right started. Why are we talking about this for a long time now? So the basic premise of this thing is nobody builds just one. Okay, as you know, in aerospace, defense, automotive, house appliances, every company is really working on different types of product lines. If you can move forward, Marco. And this has started to be coming to the mainstream on different sectors, including railway and, like I said, household appliances. One of the most known examples is automotive, but as you see, it's being also applied now to large machinery equipment, which is very interesting. And of course, healthcare and other things which we don't illustrate here. So why is it? Before we go into the contents, let's go see some other examples which can talk to you about this. Marco? Okay. The book that we are presenting today has been published by Wiley. It's available online. Adrian already gave you the introduction, so I just wanted to stress that we do have some application cases from different companies that you see on the screen, and if you are interested in the book, we can give you addresses and links where you can take a look and hopefully get information on how to get the book on electronic or printed manner. We did the book also with Tim Wielkens, who is not able to be with us here today, but we'll do our best to to take his place and talk about what he had to do. Go ahead, Marco. So let's start with the motivation. I think this is a very nice thing. Why to move? You always have to have a reason to go to product line engineering and model-based product line engineering. So let me give you a little example, Marco. So let's see some different examples. We'll run the video for about 1 minute, not more. Something that you might all know. Maybe you're not as old as I am to have seen these pictures in the movies, but I think you know them. And I want you to take a look at the similar animations that were done here. This is one very clear example between two of famous movies in Walt Disney's universe. You can start thinking that, well, this was probably opportunistic and or a lazy way of doing work, just reproducing animations. But as you will see in a minute, it's not an isolated example. Here you have other types of reuse, we call them that way, of animation. So you probably have never noticed this. I hadn't until Marco made this discovery. You have some other films, some other characters, how similar they are, and I think we can stop probably there, Marco. So the main thing is this was done on purpose. Okay, there was a reason to do this because if you go back to the old days, these animations that you see were made by hand, frame per frame. So if you spend a lot of time redoing things, then you will probably your cost explode. Your cost would explode. Your production cost would be too high. So this was a very smart move, but it was thought of from the beginning. Okay, and this is one of the reasons that product line engineering has come to the mainstream nowadays. If you move forward, Marco, now how does it work? Okay, there are different ways of doing product line engineering. Most of the time, if you advance a little, Marco, most of the time you have something that you've produced in the past and you say, hey, this looks like a nice thing to do for another customer. And you do what we call clone and own or copy and paste. Now, the problem with this is that for every customer, you will try to do the same thing. So at a given point in time, the reference that you use to this clone and own has become so different from the first one that conciliating this or merging this, if you have in mind a branching type of working, can become very, very problematic. And every time you do a clone and own, we are basically spending the same amount of money to produce the solution for a given customer. If we move a little bit ahead, Marco, just to compare, the next step, and this is very typical in many, many industries, would be what we call applicability matrices. Okay, applicability matrices just tell you for this customer, I have here in columns probably my features or my functions. You can imagine, or my requirements. You can imagine any of these artifacts that can go through this type of applicability matrix. If you have only a handful of customers, I think you can manage that, of course. If you have a business that's successful, you will probably end up managing between 10 to 20 to even 50 customers at the same time. And if you think, for example, about requirements, what if one of these customers requires something a little bit more specific than what you already had in your requirement databases? What people usually do is just duplicate the requirement and modify it. So we come back to the previous problem. So it can be useful if you're not moving in a very complex world. But as you know, there's another problem between the way the systems today are evolving with more demanding capabilities, more interconnectivity, more intelligence, or even artificial intelligence. And there's a gap between these needed capabilities to deliver the right system and our engineering tools. So how do we tackle this? This is part of the things that we are trying to explain in the book. It's your turn, Marco. You can go ahead.
Yes. So, can you hear me well?
Yep.
Good. Okay. So, as Guillermo said, let's have a look at the foundation. The foundation is what needs to be there in order to build up on top of it and to facilitate the reuse, the strategic reuse. So, first, today, nowadays, we have not just increasing capabilities, but also we have increasing complexity in the products we develop. Even if the interface of the product that we develop, they look quite simple, but the behind the scene and UI engineers, systems engineers, it's quite complex. Okay, and this is because you have like project complexity, multi-location. You have the work share of the deliverables and the work, the different technologies, and you don't do it only once, as Guillermo mentioned at the beginning, but you do it for multiple variants. So you repeat these n times. And then you need to do that not for a single discipline, but in systems engineering, we want to bring together and harmonize also the collaboration across disciplines. And that includes software, geometry, performances, safety, and variant management. Now, even if you take the smartest architect, chief engineer in your organization, the smartest engineer's brain, he will never be able to grasp everything in his brain or in our brain due to the complexity that we experience. Now, sometimes the answer is to bring more brains, but more brains in many cases means different perspectives, different problems, different way of seeing the things. So equal more challenges. So it's not always probably a good solution. This is because when you have a complex products and you have variability, so you have a variation of those complex products, it's very hard to just do it in the old-fashioned way with just the usage of our brain, right? Or tools like Excel and similar. So how can we deal with this increasing complexity and variability? So let's recap a bit. It's not that you need a complex, advanced way to manage variability in all the circumstances. So if we take two variables here, the complexity and the variability, that we can summarize it as a number of variants that you have to develop for the same system, then we can see that if you have low complexity and low number of variants, you can do like Disney did, no? Clone and own. So you can copy, they develop one movie every 2-3 years, and then it's okay for them to use this clone and own approach, right? So the complexity is not that high because we are talking about animated movies. So you can deal with this clone and own approach, how they succeeded and how they managed to do that. But the moment we increase the complexity, we need to bring other tools and other methods into the game. And one is what Guillermo mentioned, the applicability matrix or configuration matrix, where you have multiple products, multiple features, capability, requirements, how you want to call them. And then you tick the box when the capability or the feature is applied in the specific product. Again, if you have 5-6 products, you just deal with one asset, so with requirements or with capabilities or with features, then which you have this only one dimension, it may work. Okay, but the moment you increase complexity you have multiple domains, you have a more complex system, and you increase the number of variation of your system, then these approaches are not enough. So if you really want to work efficiently and effectively, so we recommend, that's why we wrote the book, to follow model-based product line engineering. What is model-based product line engineering? Well, in a nutshell, it's the combination of model-based development, or model-based way of doing systems engineering, and the product line engineering. So why we need both? For two simple reasons. Model-based systems engineering and model-based development ensure the single source of truth, ensure the traceability, the consistency, the collaboration part. Okay, so that's the biggest. Without that, without the system domain, without the system area, and without the usage of models, it would be much harder to ensure these qualities. Now, what product line engineering is bringing? They are bringing the reusability, the systematic reuse, and the single source of truth, but for the variability, what we call also single source of variability. So it means that we need both. So usually what we have seen, Guillermo, myself, team, we've seen that there is a lot of investment in companies for MBSEs. But when they develop the MBSE approach for one specific project, then in many cases it's difficult for them to reuse those models, right? And one of the main reasons is that because these models are not made to be reused. Okay? It's more like they're optimized for the system, the single system that they have to serve. So what if we bring this reuse aspect in our models, of course also in our requirements from the beginning, so that we can already think about and plan our design with reusability in it. Okay, so that's the product line engineering part, what is bringing to the game. So that's why we need both, so the model-based, the MB part, and the PLE part. Now, where this comes from is not that we invented it, so somehow. So this has its own origin in the standards, in the norms, and we have two main standards that you have to remember. One is the 26550, first published in 2013. And then we have the new standard that is not that new anymore because it's over 5 years old. Sorry, over 4 years old. That's the 26580. So which is the main difference between the two standards? Both talk about product line engineering. So the first standard doesn't introduce formally the usage of features and the PLE factory, the PLE configurators, and the model-based approach. While the second standard introduced these three things, elements. So the features, the feature-based approach, that we will look at it, what it means, the PLE configurator, PLE factory, and the usage preference of usage of models, right? So in other words, we can say that if we take the INCOSE vision and we look at the INCOSE vision that says the last three visions said that the future, the present, the future of systems engineering is model-based. And since PLE is one of the enabling methodology of systems engineering, Adrian mentioned the SE handbook, right? So you will see that there's one chapter of the SE handbook in the enabling methodologies. So PLE is part of it. So if it's PLE, it's part of a system engineering approach. Also, the system engineering is model-based. The future of system engineering is model-based. Also, the future of PLE is model-based. Okay, so we can start with this axiom to continue and to motivate why we need the MBPLE, model-based product line engineering. But of course, let's have a look at how we can implement this. Were just some foundations, some concepts that it's clear, it's good to have in mind before we start working with it. So first, we summarize here the standard. So the standard, the norm, the ISO 26580, includes several parts, several pieces. So let's start with what on the left we call share asset superset. So it's basically, let's consider this as a big library of all your assets, requirement, test cases, CAD, bill of material, system models, software codes, all the assets that you need to develop your product. So now this is where they are stored. Now the focus of these assets is not just one product, but a series of products, multiple products, what we call product line or product family. Now, how do you manage the organization? How do you manage to control the reuse and the configuration of those assets? Well, we need something called feature models. Feature models basically is the syntax and are the rules that tells you how to use these specific assets, how to configure these specific assets. And then we have also the different configurations. So for each product, you will have different configuration, feature configurations. So if you have product A, you will have one configuration of features. If you have product B, you will have another configuration of features. And then we have the so-called PLE configurator. That's kind of car configurator, but instead of configuring the physical cars, you are configuring the assets, the engineering assets that you need to develop the car, to design the car. And all of this the final result is the creation of product models. It's the creation of instances of your assets, of requirements, of your models, of your source code or bill of materials that you need for one specific product. But they're not developed in isolation with clone and own. They are derived from a superset that is this shared asset superset. So that's in summary, in few words, what the ISO 26580 says about product line engineering, feature-based product line engineering. Let's have a look now in simple step what it means. Now, first, you need a place to define the rules, to capture the variability of your product line or your product family, and to define the rules, how you are going to configure your product line and the assets in a way that you can derive multiple products out of it, multiple variants out of it. That's the feature model. Then we have the second part, that is the share asset supersets. That's basically the collection of all the engineering assets that we have that you want to reuse. You want to filter and reuse across variants. How do you know how to filter and reuse them? Well, we link them with the feature models. So we link them with the feature. So the feature is kind of controlling the reuse of these assets, so that we can come up with how do we control them? By creating multiple feature configurations, we will see. And the final result, as I mentioned, is the product model, the instances of the assets for the specific variants that you need to develop. So that's a bit like the workflow. Of course, this is not like there is a lot of iteration. It's not like always in this sequence. You can go back to one step and go forward and go back so many times. And this is basically the simplification of what I showed before from the standard. So now, simple example. What is a feature model? I mentioned several times feature model. That's how it looks like. It's very simple. So if we have now a drone example, you will see that you have several features here, hierarchically distributed. It's like we call feature tree. You can see that there is some features that are mandatory, like the range of the drone. And then you have alternatives, like standard range and extended range, or the mission of the drone, and you have alternative missions. So the three of them. You can also have or. It means like that they are not mutually exclusive, and you can have multiple regions selected here, not just one. And optional, it means that it's a Boolean feature, so either it's there or not. That's a very simple way to describe a feature model. And we may also have constraints. We can say that one features exclude another features, or one features requires another features. That's how a feature model looks like. A famous tool, I'm also part of the company. It's Pure Variants by PTC that manage exactly this type of feature models. But then, of course, we need the assets. In this case, we pick up a model, and it's a SysML v2 model because of the drone, of the architecture, high-level architecture of the drone. And we can see here now that you have several parts, and there are some variation in the structure of the drone. You have multiple type of engines, you have different type of batteries, and you have different type of payloads. Now, how do you know how to filter the different parts and instantiate from these multiple choices that you have for your specific structure, one structure only for one specific product? Well, we have to link this model with the features. So we link the features with the parts in your architectures. And once we do that, then we can select here. We have three configurations for the drone. You can see on the right side, we have a delivery drone, we have a monitoring defense drone, and we have inspection drone. We have selected some features for one drone, but not for the other drone, and then the other way around. And then by selecting this feature configuration, we can derive This, for example, the delivery drone configuration, how it looks like in details. And then we can derive the part of the models. Now, the same approach can also be applied. So this is basically this part, right? You see, so now it's the 100% here. It's not the full architecture, 150% architecture with all the options of your drone architecture. It's just the filter part for the feature that you have selected, the feature configuration that you have selected. You will see you have just 6 engines, one type of battery, and there is the large payload attachment. So this architecture has been controlled by the feature model. The same thing we can apply to requirements. So here you can have the requirements, and the same thing we could do that for requirements, independently if the requirements are in DOORS, Codebeamer, Polarion, or in Word. Hopefully not in Word. You can apply here the variation for the standard and long range requirements, you see, and if you select the feature standard range, you will select this requirement. If you select this feature, you will select the other requirement. So basically the approach is the same to models and to requirements as well, and is always controlled by the same feature model. So last but not least, this was for many people PLE, yeah, but it's not as intuitive as it looks like. It's complicated. You need expertise. Yes, that's why we have people, experts in the field, and only myself, I lead a team of 14 experts on PLE. But this sometimes could be also, we could help organization with also in other ways. So today we have artificial intelligence, and we can also take advantage of artificial intelligence and apply to the adoption of PLE, right? So that's why we can have AI as a domain expert for PLE. We can have AI as a model-based expert for PLE. So it means that in one case, it will be expert on the domain, if it's automotive, defense, and you are the MBPLE expert that knows what to define, formalized in terms of methodology, but doesn't have the expertise of a specific domain. In the other case, you have the expertise of the domain, but you want to learn more about the method and the application of PLE and MBPLE. So in this case, we can also take advantage of AI, and that's what we talk in the book about it, in order to speed up the adoption and the learning and the adoption of MBPLE. So this was very condensed, I would say, crash course on what MBPLE is and on the implementation part. And I will hand over now to Guillermo that will guide you to the adoption of this discipline.
Yes, thank you, Marco. So as you see, we have seen that the book covers different aspects, and this couple of aspects I'm going to talk to you about are also part of the book. So it's quite rich in terms of information and return of experience that you can find there. In this adoption, sorry, Marco, in the adoption, the first thing that we came up as an idea is that sometimes we all struggle in our companies to advance or make advance initiatives like SE or PLE or MBPLE. So what we try to do here in this chapter in particular is giving the elements for you to be able to build your own business case with different elements. One of the elements appears here on the left of the screen. It's a very simple one. If you take a look at the two lines here, the yellow line represents the cumulative costs when you are doing business as usual, that is clone and own and modify. So this straight line represents the fact that with these types of approaches, you usually don't improve a lot the way in which you are making business. One of the causes for this is that if people do not master what the object that they are cloning, they do not know about the technical depth that comes with it. We usually tend to conduct extensive integration, verification, and validation campaigns. So there's no advantage in doing that year after year. While the blue line represents what would happen with an MBPLE approach. As you can see, the blue line starts a little bit higher than the yellow one because indeed you require a little bit more forethought and investment to put in place a product line approach. So you're always going to, let's say, have a handicap at the beginning. If you take a look into literature, between the third, second, or fourth instantiation of a product line, you start to get to your equilibrium point or your balance point. This is where the two lines cross. From this point on to the right, the area between these two curves represents all the benefits that come with MBPLE. And I suspect that this effect is, by experience, not only linear, but superlinear, meaning that every time you will decrease the blue line, making the gains more important. The thing here is, the more you do, the more you gain with the NBPLE approach. Uh, Finally, the gray boxes that you see here is what usually happens in industries. You never have the $4 million or the 5 million euros to start a product line. You will always get a little bit at the beginning, then a little bit more at the end, and second year and third year, and so on and so forth. But this is quite positive for the case of MBPLE, because your equilibrium point, these where the two lines cross, usually tends to arrive earlier. You see, because your investment is lower, your gains are probably higher to get there, and that's one of the main effects. I will not comment on the second image that you see there, but imagine that you could make the sum of the accumulated costs not only for your first delivery, but also in time for the many deliveries that you will have. And the differences that you see between these three lines are: black is business as usual, blue would be MBSE alone, and yellow would be MB plus PLE, which is MBPLE that we are talking about. I will not comment on that because we don't have the time. But if we move forward, Marco. So another thing that's very useful when you're trying to think of how to get to model-based product line engineering, if you find this is interesting for your business, is that there is no one single road to get there. Many companies move either from document-based systems engineering to model-based systems engineering for single system deliveries, for instance. Other companies move from documented systems engineering for a single system to product line engineering using the same types of methods and way of working. And then each of these two different paths, when you add the product line or MBSE on either side of the quadrant, can lead you to model-based product line engineering. The message here is that the way you will move in this quadrant depends a lot on your particular business case, on your particular circumstances in which you are operating your business. Okay, so this is something that you really have to think about. What would be the best place to go? Or if you are already in MBSE, for instance, then it would be some sort of natural move to PLE if your business so requires. Okay, these are the types of elements that we give in the book. Another thing that we insist on in the book for making the adoption a little bit more easier is that you have to think not only on the tooling and process and method dimension. Okay, this most of the time means that the way you are going to conduct your business is going to change. So this also means that there's a company-wide transformation of all the dimensions that you see here. And we found it very useful to think about processes, methods, the information model that will underpin all of this, the tool chain, of course, and one of the biggest chunks is people and organization. So we also give some sort of advice, and in the returns of experience, you will also find some little traps that people fell into that you could avoid to be a little bit more swift in arriving to a successful implementation of MBPLE. So it's a multidimensional problem. it's not just an engineering problem. So you have to be very aware of that. That's why it's a nice adventure to live, I think. If you want to move to know a little bit more, you have the INCOSE PLE International Working Group, chaired today by Marco and Roland Arbin from General Dynamics. Uh, you have a lot of information in there. You can see the work that's been done in the past, our participation to the different standards, our participation to the System Engineering Handbook, and of course the events that we always organize around the two main events of INCOSE, the International Workshop and the International Symposium. We are one of the fastest growing working groups in INCOSE. We've been so for the last, I don't know, probably 12 years now. So I think the interest in the topic is growing. So you can find a lot of information and a lot of networking in the group. So to end this part, and before we go to the conclusions, I just want to present you very briefly a couple of industrial use cases. We have 4 different in the book, and we want to enrich this in the future. The first one is a very nice view on variability management. Okay, in Airbus, our business, one of the Airbus commercial aircraft, of course, our business is selling airplanes. Okay, when you try to design an airplane, you have many different dimensions that you have to take into consideration and coordinate to make this a little bit more effective, cost effective, I would say. You have, of course, the variability in the product dimension. You have, of course, also something that's relatively new. It's the variability of the industrial system. Okay, because every time you do an aircraft, depending on the family we are talking about, you will always have to modify little things depending on what a particular customer wants, for example, to manage all the interiors. And you also have the services dimension that can uh, bring variability. For example, if you have different service level agreements, levels of service level agreements, this can be very nicely formalized in a feature based. And these 3 dimensions have to be connected because we are not selling factories, we are not only selling services, and we are not only selling aircraft, we're working on the 3 dimensions at the same time. Of course, when you go into the aircraft, you can find variability at the aircraft level. You can find variability of the main components or subsystems, all the way down to elementary parts. So this is also part of the variability model that should help you conduct your business. On the lower side, we also want to start putting the accent on the different dimensions, on the business dimension, the operational, the functional architectures, the logical architectures, the physical, even for services, the way our own customers operate and manage the aircraft that we are delivering. These are all dimensions that can help you build a very good uh, feature model that goes all the way up from the business way down to the components. And of course, if we think about our different family of aircrafts from 320, 330, 350, you name them, we also would like to start managing variability across these different product families. And this is the 4th dimension that we are trying to tackle right now. So a very nice exercise here, a very nice explanation on how this can be managed correctly. This is more like a description, theoretical description of how can this be done for a company such as Airbus Commercial. And the second example is a little bit more down to earth. I also know that very well. I worked in Thales for a long time. It's about radars, ground master radars product lines. Now, what's interesting here compared to the previous one is that our colleagues from Thales kindly agreed to tell the story of how they went into product lines. And this is super rich. It took them some years. We are not going to hide that. But every time that they wanted to move forward, they came up with this, which is could sound like common sense, but with this brilliant idea of showing the benefits of what they were doing very concretely on the whole radar product line, to have sponsorship and finance and so on and so forth. To make a very long story short, this is a business in Thales that was in danger of extinction. It was really one point in time when they said, either we change or we close the business. And this is the story that is told here. And the end of the story, I'm going to spoil it for you, but it's not important, is that it's today one of the most successful radar businesses worldwide. Okay, so think about it that way, and then you have more arguments if you want to move into MBPLE within your own organization. Marco, do you want to do the conclusions together? You want to take them?
Well, I can take that if you want. Yeah. So, well, as Guillermo mentioned, there is a lot to say, and if you want to know more, that's why we wrote 336 pages in the book. And so, well, the main point I would like to connect them to what I already mentioned before. Don't reinvent the wheel. So there is like a standard that's a good way to start, and this is the ISO 26580. Look at the standard. The standard says that you need a single source of variability, like the orchestra that you see on the cover of the book. You need like a way to orchestrate the variability across the domains, and including all the dimensions that Guillermo explained for the Airbus case. And so basically the standard is there, and if you also would like to know more, and if there is expertise outside, right? So if you want to know more beyond the tool, but also on the PLE approach, as I said, you can get in touch with me. So I have like around 14 people working for me that are all PLE experts. So, and get in touch with us. If you want to ask questions, you can always reach out to me, to Guillermo, to Team Vikings as well. So don't reinvent the wheel. Okay, so that, and there's the PLE working group, of course, right? So these are all signs that have a look at that before. Oh, I found another way for reuse. Okay, before doing that, have a look at what has been done. Then we have like the MBPLE factory. So is it really possible? So we have many organizations working on that. It's not just a tool. You need the factory. So you need the pillars the framework that Guillermo mentioned. You need the information model, the methods, the standards. You need the processes. And so is everything there, right? So you need to evaluate the speed of relevance of your organization. Where is your organization? Where is the maturity of organization? Because you cannot go from a document based to MBPLE overnight. As Guillermo said, you need to understand where are you and what you can do with your organization. Last but not least, since I'm also now a tool vendor, so I passed some years ago on the darker side. That's the tool vendor side. I can say that also tool vendors still have to make some work on the integration. So today I would say on the ALM, application lifecycle management, MBSC and PLE, we are quite good. Now, the next steps, what we are working on, for example, my organization is working on, but not only my organization, PTC, is the integration with the PLM part. So really bridging them together, the ALM words and the PLM words, because at the end of the day, variability doesn't matter if it's ALM or PLM, right? So you have variability in the system and you need to implement it, right? So this distinction needs to be somehow broken down, right? So that's what we are working on. Yeah, so that's it from our side. So as I said, please, you can scan the code if you would like to order the book or have a look at the book. And we will take now times to answer some questions. If there are some questions, I think we have 10 minutes left, if I'm not mistaken. And I hand over to you, Adrian.
Thank you, Marco and Guillermo. Really interesting, super interesting. So yeah, we have some questions in the chat. Let's start by Misael. So he's asking, what are your recommendations of model-based product line engineering for complex projects or organizations that have an agile approach?
I can take
Guillermo,
that.
please.
Yeah, I can take that because this is exactly what I've been confronted, in particular in Thales, but also now in Airbus. Well, one of the things that you have to clarify is, well, first of all, why are you doing agile? What's the problem you want to solve by doing agile? Well, that joke set apart, you can use an agile method to build the product line. And this has two implications. One is that you have to do this very recursively. Okay. I wouldn't say it should be done like in software factory, but at least doing this in a very agile, recursive, and lean way is very beneficial. Now, once the product line exists, once this model of a product family that can satisfy different customers, the biggest value that I see in agile and the biggest difficulty is not letting your agile colleagues, like Marco said, reinvent the wheel again and again. Okay, because they would usually restart with user stories, business canvases, and all of this stuff for the next product. But if this already exists, these are assets already of the product line, then you have only be able to reuse them. So I would say the most interesting thing to me in a product line approach with agile is when you do agile to analyze the next customer call for tender or whatever in an agile way and saying, okay, we already have these things. What else is missing? How are we going to develop if these things are missing? But in certain cases, I had difficulties with my colleagues from Agile because they always wanted to start with a new concept paper, with a new thing. This already exists for the product line. Either you modify it or you went wrong and you start all over again. That would be my advice. Just
Okay.
try to find what it takes.
Great. Thanks. So we continue with the question from Eduardo Ibanez. How are the management of features related to the management of requirements? When a new variant of the product is created, I understand that a set of requirements changes.
Yes. So, Guillermo, I can take this if you
Sure.
want. So you have to consider that once you introduce your features, so you will not have their requirements and the features, right? So there you will always work together with requirements and feature at the same time. So features are linked to requirements and help you to control the requirements. So it means that if you will if you have a new variant, then you say, okay, these new variants needs new feature. So you will create new features, or you will change some of the features that you have in your feature model. And you will have to probably add some requirements that explain and better define those features, right? So the only difference that we have now between feature and requirements is that feature only focus on the variable part, okay? So it means that you may have a change in the product that includes all the variants. And in that specific case, you're not going to create a new feature because it's a common part. So you don't need to specify that to have a variable of a driver, that is the feature, that in order to control that. So in the case that you mentioned here, where you say, I will also have to create new requirements, probably for new variants means that you have requirements that apply only to some variants, but not to other variants. So how you are going to control at the end all those requirements? Well, you need the feature model. So it means that you always need to see the feature together with the requirements. So the feature controlling the reuse of the requirements across the variants. So if you change the features, if you change the requirement, likely you may need to change the features if the requirements only apply to one variant or two variants. But if the requirements, the change applies to all the variants, then you're not going to change the feature because you don't need a feature for that, since it's a common element that you will always carry over in your requirement specification. I don't know if I could explain that. Good. I see.
And
Yes,
I would add
Eduardo
just
says.
something. I would add just something, Marco. Is we talked about instantiation, and this can be seen in two different ways. Either you have the possibility to generate from the product line database a new requirement database that depends on your company and your capabilities, or you manage everything in one 150%. That's another concept we didn't talk about of requirement databases. It depends on you, and then you have everything under control, like Marco said.
Great. Well, so let's move to the following question. Also, Eduardo, some standards were mentioned, such as 26580, for example. Is there a relationship with ISO 5501 asset management as well? And using this methodology, is it possible to consider moving on to generating digital twins?
Great question. Great questions. I will take the first part, Marco, and you take the second one, which is harder. Okay. And no, there's no real relation with 55001 because the concept of asset is a little bit different than the one we are managing in MBPLE. Unfortunately, we use the same word, but to refer to different things. What we didn't find in asset management, which is a crucial thing for product MBPLE, is configuration management adapted to a PLE approach. And this we're working on because you have to keep under control the configuration of the whole product line, all the shared assets. When you instantiate them, you have also to do very specific configuration management at the instantiated level because you have to keep things under control for production and so on. And then this means you have two dimensions of configuration management, at least, which we didn't find in the asset management thing. And so no direct relation, I would say. And the second one, using this methodology, is it possible to consider moving? That's a great question. It all depends on what we know by digital twins, but I let Marco give his advice.
Yeah, I mean, before digital twin, I would like to start with the digital continuity. So establishing full traceability across the domains, right? Because that's the foundation of the digital twin. And I can bring now the example of the company I'm working with, that's PTC. So we have PLM systems, we have PLM software, we have ALM software, MBSE solution, and PLE solution, pure variants. So what we do, we have developed an integrated product engineering approach where the PLE approach is central because, as Guillermo mentioned at the beginning, we don't develop only one system, right? So we develop more than one. And that's why do you need then to do it each and every time just for a single product? You need to go through all the traceability just for one product when you can do it for the product line, no? For the product family. That's the idea behind. So for me, it's like the only difference that you need to consider is that at the end of when you link all the product line assets, all the product line domains, because the ultimate scope is to create a digital twin, it's at the end of the day something that it's realized, is implemented in real life, right? So, and it's a twin of what exists in real life. A product line does not exist in real life because a product line, it's more than one product, okay? So you can have a digital continuity, the digital traceability for the product line, and this will also help you to generate the variant to instantiate the specific instance that Guillermo mentioned, and that will be the twin of what exists in reality, right? So in other words, yes, you can use it, with the difference that you are not doing just for one product, but you are establishing the full traceability across domains for multiple products for your product line. Okay, so that's basically the So is it possible? Yes and no today, because as I mentioned in the conclusion, we as a tool vendors are still in the process of enabling this type of integration, right? And I always say, not I always say, my friend Charles Kruger, that's a competitor of me, always says that not just him, but that software is soft, so it's easy, but people are hard. So the problem of such integration is not the software, not the technology. It's always bringing together people and convincing people that's the a good way to go forward, right?
Thanks, Marco. So we are almost with, yeah, the time is almost done. But yes, Jaime has another question. Has any work been done to include PLE aspects into existing model-based engineering methodologies?
Excellent question. Not to my knowledge. This is what I started to do before I left Thales, and this is what I'm trying to with Capella and Arcadia and all that stuff. And this is what we are trying to include now in our particular Airbus methodology, MOFLT. That's called for mission operation.
Yes, on proprietary level, yes, as Guillermo said. So you have this. Airbus is one example, and I can tell because I was there. I started there, so that's why I initiated this. This is the MBSC part in Airbus. So, but the magic grid. Let's take an example. The magic grid of Dassault systems. You don't have the variability aspect there, right? So the harmony of IBM, you don't have the Arcadia one. We don't have the variability aspect inside the methodology. That's a very big, I would say, gap. On the other hand, SysML v2 has variant notation in it. So I may expect that the future, the update of those methodology following SysML v2 will have to consider the variability because now is in the notation of the language of SysML v2. That's the biggest change that we can probably experience in the near future.
Absolutely.
Okay, great. So last question from Nelson. What could be the main obstacle for small and medium enterprises adopt MBPLE?
I would say investment, right?
Yeah,
Investment
exactly. I was going that finding the right business case for you, because it will take time to convince people, and it will take time to have the elements that you can bring to the table, the numbers, I mean, that you can bring to the table to convince people and make assumptions, make simulations. That's why modeling is important, just to make simulations. But I think you might have a big advantage over large companies like mine, is that you know more people in percentage in your company than we do, and you have to mobilize less people in your company. So a smaller environment can be more favorable to discuss about the real business issues. And say, is MBPLE a solution for some of these issues? So yes, I completely agree with
Guillermo, a concrete example to conclude. Imagine you are a startup, or maybe not a startup, a small enterprise, not the startup, that is entering the automotive business, okay, and wants to develop a software. It could be a solution for the automotive business, right? And software-defined vehicles area. Now, they have maybe multiple customers. So how do they manage the development of the software in a way that can reuse and adapt it in an easy way with not having a big manpower to meet the different customer needs? And since they are a small company, the customers want to have specific tailored solution, right? So this is a particular use case of a small and medium enterprise that is entering new markets, where there, if you approach PLE on the software side, so let's focus on the software domain first, maybe software and requirements, it can really speed up the process of doing that. It can enable you doing it with less resources, and the investment is not so big, because at the end of the day, you will manage with a few licenses, with a few trainings, with a few people, you can deliver big value out of that.
Okay,
Good.
great. So, guys, we are out of time.
Yeah.
So it was amazing. Thank you for sharing this information, this book, answering the questions. It was a pleasure having you here in INCOSE Latam.
Thanks for the invitation, Adrian.
Thank you very much.
Thank you.
And I wish you a big success with the INCOSE Latam. So we need more of these chapters, no? That's inclusive
Absolutely.
chapters across countries. So excellent work, Adrian, and the team for doing that.
Yes.
And
Yes.
say
Yes.
thanks to Tim too there.
Yeah. Okay. If you have
Thank
any
you.
questions, Marco said, just don't hesitate. See you all. Thank you very
Bye-bye.
much.
Thank you.